So analysis and design of two-way slab system supported on stiff beams or walls. Because ACI coefficient method is applicable to those slabs, whether it is one-way slab or two-way slab system, it must be supported on stiff beams or walls. Okay. These are the topics which will be addressed in this lecture. Behavior moment coefficient method for two-way slab system, steps in moment coefficient method, design example 1, which is basically design of a typical house with 2 rooms and a veranda, and then design example of a 3-story commercial building having the total covered area of 100 by 60 feet. Practice examples and find references. Okay, these are the objective of this lecture. We are already familiar with one-way and two-way slab system. ACI coefficient method for two-way slab analysis and design of two-way slab system for flexure, comparison of manual, that is ACI coefficient method results, and finite element analysis results, and finally design of a typical house and a regular building for gravity loads. As you know that we have discussed it in the RCD 1 that if a slab is supported on all 4 sides, then depending upon the longer to shorter span ratio, it may be categorized as one-way slab system or two-way slab system. If longer to shorter span ratio is 2 or greater than 2, it will be categorized as one-way slab system, and if longer to shorter span ratio is less than 2, it will be categorized as two-way slab system. So the given floor plane on this slide, it is a two-way slab system because each panel is of 20 by 25 feet. It is a 20 by 25 feet panel, and the longer to shorter span ratio for each panel is 25 by 20, which is 1.25, is less than 2, so it makes a two-way slab system. Okay. This is the behavior of one-way slab system and two-way slab system. So in one-way slab system, you know that primarily the bending will be in one direction, that is along the shorter direction, and in two-way slab system, the bending will be along both direction, will bend in a cup shape. This is that floor system which you have seen on slide 4. Bending of that you can see in all panels, bending is primarily in both directions. Also you can see that the positive bending in the exterior panels is greater than the positive bending at the interior panel. Okay. And it is because the negative moment at the exterior support, it is less than the negative moment at the interior support, and that is why this moment will go toward the will distribute it toward the positive moment. This you can see here. This is the moment diagram of the given slab along the shorter direction. The blue color is showing positive moment, and the red color is showing negative moment. Okay. This is the green color which is showing 0 moment. As you go toward this side, it is the color is getting deep blue, the positive moment increases, and as the color getting keep rate, the negative moment increases. So you can see here that the positive moment at the exterior panels is greater than the positive moment in the interior panel. And similarly, the negative moment at the exterior support is very small as compared to the negative moment at the interior supports. Okay. Similarly, if you analyze the same slab system along the longer direction, so again you can see that the positive moment at the exterior panel is greater than the positive moment at the interior panel, and negative moment at exterior support is less than the negative moment at interior supports. Okay. So you know these facts qualitatively, that first of all, the positive moment at the exterior panels will be greater than the positive moment at the interior panel. And similarly, the negative moment at exterior support will be less than the negative moment at the interior support. Similarly, we also know this fact that the moment transfer along the shorter direction will be greater than the moment transfer along the longer direction, because we have derived this in RCD1, and for longer to shorter span ratio of 2, we derived that the load transfer along the shorter direction will be 16 times the load transfer along the longer direction. Okay. So you know these facts, uh, the values of these moments qualitatively, but how to calculate these quantitatively? For this you need coefficients. Like for example, in case of one-way slave system, you uh, you have some moment coefficients depending on different supporting conditions, and you multiplied those coefficients with WU ln square to calculate the moment values. Okay. So in case of two-way slave system, we also need some coefficients. Okay, to determine the moments along the shorter direction, negative and positive moment, and negative and positive moment along the longer direction. Okay. This was the derivation. If you take a point here, so the deflection will be same along the longer direction and along the shorter direction. Delta A will be equal to delta B. And if you use the maximum deflection equation for uniformly distributed loaded simple span, it is 5 divided by 384 WL4 by EI. If you put it here, so finally you will get this equation. And if LB by LA is equal to 2, so 2 power 4, so WA will be equal to WB multiplied by 16, which means that the load transfer along the shorter direction will be 16 times the load transfer along the longer direction. Similarly, if we calculate, we represent this in terms of moments. So these are the moment coefficient values. For example, for simply supported span, you know it is 1/8. Okay. If it is a one-way slave system. If it is a two-way slave system, of course it will be less than 1/8, because some of the moment will be transferred also along the longer direction. Okay. So finally, this is the equation. MA, that is moment transfer along the along the shorter direction, will be MB into LB by LA square. For example, if LB by LA is equal to 2, so MA will be equal to 4 MB, which means that for longer to shorter span ratio of 2, the moment transferred along the shorter direction will be 4 times the moment transfer along the longer direction. And that is why we categorize that system as one-way slab system, because major load transfer and moment transfer will be in the shorter direction. Okay. अच्छा, ये बात आप याद रखें, यहाँ पर कुछ नोटेशंस आप याद रखें. The length, coefficients and moments along the shorter directions, they are represented with subscript A. For example, length of shorter direction is LA. Coefficients along the shorter direction is denoted by CA. So if positive coefficient, it is CA positive. If it is negative moment coefficient, it will be CB, CA negative. Similarly, moment transfer along the shorter direction, this will be MA positive or MA negative. Okay. And the length, moment coefficients and moment transferred along the longer direction, it is represented with subscript B. So this is LB, and the coefficients, the moment along the longer direction will be MB. Okay. Similarly, the coefficient along the longer direction, moment coefficient, it is represented by CB. Got this? ये नोटेशन जरा याद रखिए. सही. अच्छा, now since you are familiar with the ACI coefficient method used for the analysis of one-way slab system, तो उसी से हम स्टार्ट कर देते हैं. For example, this is a one-way slab system. This line shows the beams connecting these columns. For example, the length of the shorter span, which is LA, it is equal to 10 feet, and length of the longer span, which is denoted by LB, it is equal to 30 feet. So first of all, tell me whether it is a one-way slab system or two-way slab system.
One way, sir.
One-way slab system. Now, if we take a cross section of this section of this plane, this is basically beam column plane. So it will look like this. Okay. Now what about the coefficients? What is the negative moment coefficient for exterior support? Shabash Sharif. It is how much? It is 1/24. For spandrel or exterior beam support, the negative moment coefficient value, if you remember, it is 1/24. And what is the positive moment coefficient value for exterior span?
1/14.
1 over 14. Okay. What about the coefficient value for the interior supports?
1/11.
Yes, 1 over 11, but since LA length is less than, clear length will be less than 10 feet, so you can put these coefficient equal to 1 over 12. इस तरह है कि नहीं?
जी sir.
And what about the positive moment coefficient for the interior span?
1/16.
1 over 16. अब इसको जरा डेसिमल फॉर्म में लेके 1 over 24 is equal to how much? Fraction form से जरा convert करें 1 over 24 on 0.
0.041 sir. 0.042.
0.041. 1 over 14.
0.07.
0.071. 1 over 10.
0.083.
0.083. Similarly, it is also 0.083. And what about 1 over 16?
0.062.
0.062.
Sir. 625.
And again, this is 0.083 and 0.083. If we mark these values on the plane, for example, if we are taking this interior panel, okay, so the negative moment coefficient, negative moment on this support and on this interior support, it can be calculated from the negative moment coefficient, which is equal to 0.083. इस तरह है कि नहीं? Clear? And the negative moment coefficient, the positive moment coefficient for the interior span, it is 0.062. इस तरह लिख सकते हैं? हेलो?
Yes, sir. Yes, sir.
अच्छा, अब अगर मैं इनको since I told you that the coefficients along the shorter direction, the moment coefficients length along the shorter direction can be represented with subscript a. So I can represent these coefficient generally with CA and negative moment coefficient, है ना? And since it is along the shorter direction, so I can represent it with CA. Clear? Similarly, this is CA negative, and this can be represented by CA positive. यहाँ तक clear है?
Yes, sir.
So CA negative. So you know the values of CA negative, CA positive, and CA negative along the shorter direction for one-way slab system. Okay? यहाँ तक बिल्कुल clear है?
Yes, sir.
Now what about the coefficient values along the longer direction? ये जरा मुझे बताएं. I mean to say that what will be the value of CB negative and CB positive?
Sir, 1/16 and
Anyone else? जी अच्छा, मैं आसान कर देता हूं। ये वन वे स्लेब सिस्टम में कि टू वे स्लेब सिस्टम?
वन वे।
one way, sir. One way, sir.
तो आप जरा बताएं दी कोफिशिएंट वैल्यूज अलोंग लॉन्गर डायरेक्शन।
One more eight, sir.
Okay, can you see the slides?
No, sir.
No, sir.
Is it visible now?
Yes, sir.
Yes, sir.
अच्छा, what about the negative क्वेश्चन समझ में आ गई?
नो सर, सर आपकी आवाज नहीं आ रही थी।
अब आ रही है?
यस सर।
Yes, sir. अभी आ रहा है।
अच्छा, ये मुझे बताए, यहां तक तो समझ गए ना? दी कोफिशिएंट along the shorter direction,
यस सर।
negative and positive coefficients, C a negative and C a positive along shorter direction। यहां तक समझ गए?
यस सर।
अच्छा, अब ये मुझे बताए what will be the moment coefficients along the longer direction, these coefficients, that is CB negative,
Sir, one more eight.
anyone else?
Longer direction में movement transfer होगा sir.
जी बताए जोर से।
One way slab नहीं है.
One way slab, it is a one way slab system, okay? So will there be any moment transfer along the longer direction?
No, sir.
No, sir.
No. So what will be the value of CB negative and CB positive?
Yeah, right.
Almost zero.
almost zero. बिल्कुल.
Yes.
So CB negative and CB positive for one-way slab system, it will be 0. It will have the Ca negative and Ca positive coefficient value because the load transfer is along the shorter direction. But Cb negative and Cb positive is 0 because there is no load transfer along the longer direction. Okay, यहाँ तक clear है?
Yes, sir.
Yes, sir.
Yes, sir.
बिल्कुल clear. Now, for example, if the longer direction, the length of the longer direction is 18 feet instead of 30 feet. अब मुझे बताएं, it will be a one-way slab system or two-way slab system?
Two-way slab.
It will be a two-way slab system. So first of all, tell me that what about the CB negative and CB positive? इसके वैल्यू अब होंगे कि नहीं?
Yes, sir.
Yes, sir.
It will have some values. Okay, CB negative and CB positive will have some values. Understand? And what about these coefficients, Ca negative and Ca positive? It will remain the same, it will be increased, or it will be reduced?
Reduce.
Reduce.
Yes, it will be reduced because now some of the moment is also transferring along the longer direction. So these coefficients will be reduced. तो इसका क्या मतलब है? इसका मतलब है Ca negative and Ca positive, these will be reduced and there will be some coefficient values of Cb negative and Cb positive. अब बात समझ में आ गई? Clear?
Yes, sir.
Yes, sir.
So this is the summary of this lecture. इस लेक्चर में हम क्या करेंगे? Ca negative, Ca positive along the shorter direction इसको कैलकुलेट करेंगे और along the longer direction we will calculate Cb negative and Cb positive. Okay, and once we calculate these coefficients, multiply it with its respective lengths to calculate the moment. For example, if you calculate Ca negative, so Ma negative will be equal to Ca negative multiplied by W multiplied by La square. Okay, similarly Cb negative, Mb negative will be equal to Cb negative multiplied by W multiplied by Lb square. In the previous case, if you remember, we multiplied it with only this shorter direction length, Ln square. Remember that? But in this case, the moment will be transferred along the shorter direction as well as along the longer direction. ये बात समझ गए? तो ये इस लेक्चर का की समरी है कि इसमें बस आपने ये कोफिशिएंट्स कैलकुलेट करने और उससे मोमेंट्स along the shorter direction as well as along the longer direction. Clear? यहाँ तक कोई क्वेश्चन है?
No, sir.
No, sir.
अच्छा, अब इसमें एक मजीद इसमें एक डिफरेंस ये है कि पॉजिटिव मोमेंट्स नेगेटिव मोमेंट के लिए इट रिमेन्स द सेम. फर्स्ट ऑफ ऑल यू विल कैलकुलेट द Ca negative, okay, and from Ca negative you can calculate the moment along the shorter direction. Very simple, it will be equal to Ca negative multiplied by ultimate load Wu and multiplied by La square. Similarly, you will calculate CB negative. For negative moment, it remains the same as you discussed, as you studied for the one-way slab system. It is CB negative multiplied by ultimate load multiplied by longer direction length square. Okay, but ACI coefficient method for two-way slab system treats the positive moment coefficient separately for live load and dead load. Okay, so what you will do for positive moment along the longer direction or along the shorter direction, this is CA positive. For dead load, okay, and CA positive for live load. एक कोफिशिएंट नहीं होगा बल्कि दो कोफिशिएंट्स होंगे डेड लोड के लिए और लाइव लोड के लिए. You will calculate, you will pick the coefficient separately from separate tables. सही. Similarly for अच्छा, अब इससे फिर आप मोमेंट ट्रांसफर along the shorter direction किस तरह कैलकुलेट करेंगे. MA positive, it will be equal to CA positive dead load into ultimate dead load, क्योंकि ये dead load coefficient है, multiplied by LA square because it is along the shorter direction, plus CA positive live load coefficient multiplied by ultimate live load multiplied by shorter length square. Okay, this will give you the positive moment along the shorter direction. Okay, similarly you can calculate the positive moment along the longer direction using two coefficients, that is longer direction positive moment coefficient for dead load and positive moment coefficient for live load. Okay, आप CB positive dead load and CB positive live load इसको कैलकुलेट करेंगे और उससे फिर आप मोमेंट कैलकुलेट करेंगे. It will be equal to CB positive dead load multiplied by ultimate dead load multiplied by longer side length square plus CB positive live load multiplied by ultimate live load multiplied by longer side square. So you can see total 6 coefficients will be required. CA negative, CB negative, CA positive dead load, CA positive live load, CB positive dead load and CB positive live load. Clear? And for these coefficients, 6 coefficients, 6 separate tables are given, and from those tables you can pick the respective coefficient values. for different supported condition and for different longer to shorter side span ratio. Okay, यहाँ तक clear है? Any question?
Yes, sir.
So of course these coefficient values will depend on supporting condition, क्योंकि आपने E1 में स्लैब सिस्टम में भी पढ़ा था, if you remember. देखिए यहाँ पर आपके पास 1/24 है. Why? Because it is exterior support. Supporting condition is different. For interior support it is 1/12. Okay, for exterior span it is 1/14, interior span 1/16. So you can see that these values will change with different supporting condition or boundary conditions. Okay, so similarly the coefficient values for two-way slab system will also change with different boundary conditions. Okay, but it will also change with different longer to shorter span ratio or shorter to longer span ratio, because you know that as you are as the longer to shorter span ratio increases, the load transfer along the shorter direction will increase. Okay, तो supporting condition यहाँ से आप देख सकते हैं. Again this is the same floor system. Okay, the column size for example in this case is 12 inch by 12 inch. Okay, and the beam size is 12 by 18 inch. The center to center length of this panel is 25 feet and this is 20 feet, and you can see the different boundary condition for these different panels. For example, panel 1, in case of panel 1 you can see that the two sides of this panel, they are continuous supports, and the other two sides, they are discontinuous ends or discontinuous supports. Okay, similarly if you see panel 2, the boundary condition of panel 2 is such that all the three sides are continuous and one shorter side is discontinuous. Okay, panel 3, all the three sides are continuous and one longer side is discontinuous. Okay, similarly panel 4 has different supporting condition or different boundary condition. All the four sides in case of panel 4, they are continuous supports. Okay, यहाँ तक clear है? So with these different boundary conditions, the value of these coefficients, these 6 coefficients, it will change. Okay, and it will also change with the shorter to longer span ratio, which is represented by M. In this case the longer to shorter span ratio, it is 20 by 25, but since it is LA divided by LB, so LA is basically the clear length, clear span length along the shorter direction, and LB is the clear span length along the longer direction. So clear length along the shorter direction is 20 minus support width, which is 12 inch, so 1 feet, it is 19 feet, and LB is equal to 25 minus 1, which is equal to 24. So LA divided by LB will be equal to 19 divided by 24. It is how much? 19 by 24.
0.79.
0.79. So it is closer to 0.8. So we can take m is equal to 0.8. So for m is equal to 0.8, and for these different supporting condition, we can pick the value of those 6 coefficients from 6 separate tables. और आगे आप देखेंगे कि किस तरह हम पिक करते हैं. सही. This is panel 1, in which 2 ends are continuous and 2 are discontinuous. Panel 2, 3 sides are continuous and 1 side, shorter side, is discontinuous. Panel 3 and panel 4. Okay. हम इसको इस तरह मार्क कर देते हैं. And if you analyze these 4 panels, you have analyzed the complete floor, because you can see all the other panels are similar. If you see, this is panel 4, it is similar to panel 4. This is similar to panel 1. This is similar to panel 3, similar to panel 2, panel 1, 4, 4, and 1. So if you analyze these 4 panels, it means that you have analyzed the complete floor. Okay, because all the other panels are similar to these 4 cases. Okay. यहाँ तक क्लियर है. अब इसको जरा सॉल्व कर देते हैं एज एन एग्जांपल. फॉर एग्जांपल द स्लैब थिकनेस, आगे हम कैलकुलेट करते हैं कि हाउ टू सेलेक्ट द स्लैब थिकनेस फॉर 2 स्लैब सिस्टम. मगर यहाँ पर चले हम एज्यूम कर देते हैं स्लैब थिकनेस इज इक्वल टू 6 इंच, सुपर इम्पोज डेड लोड इज इक्वल टू 60 piece of pound per square foot, and live load is 40 pieces. It is 40 pound per square foot. Okay. From this we can calculate the self weight, which will be equal to 6 divided by 12 multiplied by 150. How much it is coming? I think it is 75 pieces. Confirm kare zara.
Yes sir, 75.
Yes, sir.
Okay. So what will be the total dead load? Total dead load will be equal to how much? 75 plus 60, which is equal to 135 psf, or pound per square foot, or 0.135 ksf, that is kip per square foot. Okay. Similarly, live load is equal to 40 psf, or it is equal to 0.04 ksf, kip per square foot. From this you can calculate the ultimate dead load, WU dead load. It is equal to 1.2 multiplied by 0.135, will be equal to how much? 1.2 multiplied by 0.135. Hurry up.
0.162.
0.162 ksf. Okay. Similarly, WU live load, that is ultimate live load, is equal to 1.6 multiplied by 0.04, is equal to how much?
0.064, sir.
0.064 kSF. Why we calculated it differently, ultimate loads, dead load and live load? Because we need it for positive moments along the longer direction and along the shorter direction, okay? And we also need the total ultimate load, which will be used for negative moment, and it is equal to 0.162 plus 0.064. It is equal to how much?
Point 0.226.
0.226 kSF. So remember these three values. You will use these three values in calculating the moments along the longer direction as well as to calculate the moment along the shorter direction. Okay. Now, first of all, we will calculate the m value, which is equal to 0.8 in this case, and then we will decide about the case. For example, we are analyzing panel 1. So first of all, focus on this panel 1. Okay, हम इसको एनालाइज करते हैं, इसको जरा गौर से देखें. सही, we are analyzing this panel 1. M is equal to 0.8. So coming to these tables, this is table for CA negative, table 1, table 2 for CB negative, table 3 for CA positive dead load, table 4 for CB positive dead load, table 5 for CA positive live load, and table 6 for CB positive live load. So I told you that we need 6 coefficients, and for calculating those 6 coefficients, 6 separate tables are given. Okay. अब इसमें आप जरा देखें, if we are calculating for example CA negative, you can see there are m values in the left column. In our case, it is 0.8, shorter to longer span ratio. It starts from 0.5 up to 1, because LB divided by LA is equal to 2. From this, the two-way action starts. If we take reciprocal of this, that is shorter to longer span ratio, so it will become 0.5. And it is 1 because it is a perfect square panel. In this case, the load transfer along both directions will be the same. Okay. In our case, M is equal to 0.8. We have calculated this, and these are different cases. The dot line shows continuous sides, continuous supports, and the solid line shows discontinuous ends or discontinuous supports. Similarly, the horizontal sides, which you can see here, they are showing the longer sides, and the vertical sides, they are showing the shorter sides. Okay, clear? The dot lines are showing continuous ends or continuous supports.
Yes,
Solid
sir.
lines show discontinuous ends. Horizontal sides are showing the longer sides, and vertical sides are showing the shorter sides. ये clear है?
Yes, sir.
Yes, sir.
अच्छा, अब इसमें जरा बताएं, panel 1 corresponds to which case? Two sides are continuous and two sides are discontinuous.
Yes, sir.
कौन सा केस है?
0.071, sir.
Case 4, sir.
case 4 है, because you can see two ends are continuous and two ends are discontinuous. Okay. अच्छा, what about panel 2? Panel 2 corresponds to which case?
Case 7, sir.
Case 7, sir.
Solid lines are showing continuous, discontinuous supports, and dotted lines show continuous supports. अब बताएं.
Case 9.
Case 9.
Case 8 or case 9?
9, sir.
Case 9.
9.
Because in this case you can see that all the three sides are continuous and one shorter side is discontinuous. So you can see here that it is corresponding to case 9. Okay. What about panel 4, panel 3?
Case 2.
Case
Case
2.
2, sir.
Yes, case 2.
Case
Yes,
2, sir.
exactly. And what about panel 4?
Case 9.
Case 8.
Case
Case
8.
It is case
Yes,
8
yes, sir.
because the longer side is discontinuous in this case. Okay. Clear?
Yes,
Yes,
sir.
sir.
तो अब हम इसको जरा एनालाइज कर देते हैं. फर्स्ट ऑफ ऑल वी विल एनालाइज पैनल 1. ओके, तो ये जरा आप नोट करें. पैनल 1 को हम एनालाइज करते हैं. सही. तो फॉर द एनालिसिस ऑफ पैनल 1 वी नीड 6 कोफिशिएंट्स. ओके, वो हम लिख देते हैं यहाँ पर. We need Ca negative, Cb negative, Ca positive, dead load, Ca positive live load, Cb positive dead load, and Cb positive live load. Clear? अच्छा, starting from Ca negative, so table first because it is corresponding to Ca negative. Okay. Now M is 0.8 for our case, and panel 1 is corresponding to case 4. So the Ca negative coefficient value will be how much? Ca negative is equal to, hello,
0.071, sir.
0.071. तो जरा नोट करें, शाबाश, यहाँ पर नोट करें. Ca negative is equal to 0.071. Now coming to Cb negative. This is Cb negative. M is equal to 0.8. It is case 4. So what is the coefficient value? Expand करें ना.
0.029.
0.029. यहाँ पर लिखे 0.029. बाकी कोफिशिएंट्स आप अपने साथ नोट करते जाएं और फिर मुझे लास्ट में बताएं. सही. अच्छा, Ca positive dead load, you can see here, Ca positive dead load, it is how much?
.039.
ये जरा नोट करें, शाबाश, फिर मुझे आखिर में बताएं. सही। सी ए पॉजिटिव डेड लोड नोट किया?
यस सर।
अच्छा, सी बी पॉजिटिव डेड लोड, positive moment coefficient along the longer direction corresponding to dead load is 0.8,
0.061.
0.0.
16.
ये जरा नोट करें, शाबाश। फिर आखिर में मुझे बताए, सही नोट किया?
यस सर।
Now coming to the coefficients, positive coefficient corresponding to live loads. So first of all, positive moment coefficient along the shorter direction corresponding to live load, CA live load, 0.8, case 4. What is the value?
0.048.
ये जरा नोट करें, शाबाश। And finally, the CB live load, that is the positive moment coefficient along the longer direction corresponding to live load. It is 0.8, case 4. So what is the value?
0.02.
0.02.
0.02. ये भी नोट करें। नोट किया?
यस सर।
Yes,
अच्छा,
sir.
अब मुझे बताइए जरा, what was the CA positive dead load value?
0.039.
0.039. CA positive live load?
0.048.
0.048. CA positive dead load?
0.016, sir.
0.016. And what about CA positive live load?
0.02.
0.02. Now we can calculate MA negative, MA positive, MB negative and MB positive.
सर एक्सक्यूज मी
जी जी।
सर, ये काइंडली पैनल में जरा ये कंफर्म करवा दे सर, इसकी समझ नहीं आई थी कि मोमेंट नेगेटिव किस डायरेक्शन में होगा और पॉजिटिव किस में लेंगे सर। पैनल में ये जरा समझा दें सर।
तो मैंने आपको समझा दिया पहले। देखिए, ये आपके पास नेगेटिव मोमेंट है, ये पैनल है फॉर एग्जांपल, तो ये नेगेटिव मोमेंट अलोंग द लॉन्गर डायरेक्शन है and this is positive moment along the longer direction. These are negative moment along the shorter direction, negative moment along the longer shorter direction, and positive
जी
moment
सर।
along the shorter direction. Okay,
जी सर।
तो दोबारा कर देता हूँ, चले। Red line shows the negative moment along the longer direction. So this is basically MB negative. Okay.
Yes, sir.
This green line shows the positive moment along the longer direction. So this is MB positive. Okay.
सर लॉन्गर डायरेक्शन के साथ बी लिखेंगे सर?
हाँ बिल्कुल, तो मैंने आपको पहले बता दिया ना। all the lengths, all the parameters, whether it is length, it is coefficients, or it is moments, or it is loads, they will be marked, they will be represented with subscript B. Okay. For example, length along the longer direction LB, coefficients along the longer direction CB, moment along the longer direction MB, load along the longer direction WB. बात समझ में आ रही है?
जी सर, जी सर, शुक्रिया।
along the longer direction जो भी पैरामीटर्स होंगे उसको हम with subscript B represent करते हैं, सही?
जी सर।
And all the parameters, all the same parameters along the shorter direction will be represented by subscript A, सही?
ओके सर।
Now this yellow line shows the negative moment along the shorter direction, so it is represented by MA negative. And finally this color represent the positive moment along the shorter direction. So it is represented by MA positive. अब समझ में आ गई?
ओके सर, शुक्रिया।
तो अब since you have these coefficients, you have calculated the positive moment coefficients and the negative moment coefficients. So using those coefficients, you can calculate the negative moment as well as positive moment along the longer and shorter direction. Okay. तो फर्स्ट ऑफ ऑल हम पैनल 1 को एनालाइज करते हैं। तो पैनल 1 के लिए हमने ये सारा कुछ किया, सही है। नेगेटिव मोमेंट्स कोएफिशिएंट और पॉजिटिव मोमेंट कोएफिशिएंट हमने कैलकुलेट किए ऑलरेडी। तो जरा इसको मोमेंट्स भी कैलकुलेट कर देते हैं, सही। फर्स्ट ऑफ ऑल वी विल कैलकुलेट द मोमेंट, the negative moment along the shorter direction, MA negative. So you have CA negative. CA negative is equal to 0.071. So MA negative is equal to CA negative multiplied by WU. In this case, we will use the total ultimate load multiplied by LA square because it is moment along the shorter direction. So we will use LA square. So ये जरा put करें, CA negative is 0.071. Okay, multiplied by WU is how much? WU हमने calculate किया था total ultimate load
0.226.
0.226 multiplied by LA is how much? यहाँ पर हमने कैलकुलेट किया था LA. This is 20 feet and if the beam width is 12 by 18 inch, so width is 12 inch, तो हमने कैलकुलेट किया था LA was equal to 20 minus 1 feet, so 19 feet. Okay, and LB was equal to 25 feet is center to center length minus support width which is 1 feet, 24 feet. ये भी जरा नोट करें, सही। Clear length of shorter direction is 19 feet and clear length of longer direction is 24 feet. Is this clear to all of you?
Yes, sir.
Clear है ना?
Yes, sir.
जी सर, क्लियर है जी।
अच्छा, तो यहाँ पर ये जरा पुट करें, LA is 19, 19 square. अब ये कैलकुलेट करें, शाबाश। MA negative is how much?
5.79 सर।
5.79, so almost 5.8 foot cube per foot. Okay, correct. Now you can also calculate MB negative. So you have the value of CB negative. What was the value? I think it was 0.029. So MB negative will be equal to CB negative multiplied by WU multiplied by, now it will be LA square or LB square?
LB square.
LB square. तो यहाँ पर जरा पुट करें, शाबाश। 0.029 multiplied by 0.226 multiplied by 24 square. इस तरह है ना?
जी सर। सर ये आ जाएगा 3.77।
3.77 foot cube per foot. Okay, तो MA नेगेटिव एंड MB नेगेटिव वैल्यूज आपने कैलकुलेट किए हैं। इसको मार्क कर देते हैं पैनल पर ताकि आपको समझ में आ जाए। तो आते हैं, पहले इसको मार्क कर दे, फिर हम MA पॉजिटिव और MB पॉजिटिव भी कैलकुलेट करेंगे, सही। Where was the panel? It is the panel. Okay, तो इस पेन पर आप देखिए जरा, this is the moment along the shorter direction. It is represented by this red line, and it was equal to how much? 5.8 foot.
8.
The moment, negative moment along the longer direction, denoted by yellow line, and it was equal to how much?
3.77.
3.77 foot. Correct? अच्छा, इसमें आप देखें the moment, what about the moment on these discontinuous end? We are taking these 0. See? Because the moment value at discontinuous end will be so small that we can ignore that value. Okay?
सर ये हर एक केस में ऐसा होगा, डिसकंटिन्यूअस पे जीरो लेंगे.
Discontinuous end पर हम 0 लेते हैं, but however we will provide some reinforcement if there is some negative moment. For that, the reinforcement which we provide at discontinuous end, if you remember, we will provide the reinforcement at least 1/3 of the maximum positive reinforcement at discontinuous end. ये याद है आपको? There was a requirement of ACI code कि आपने discontinuous end पर at least 1/3 of the maximum reinforcement आपने provide करनी है. सही? So since we will provide some reinforcement which will be 1/3 of the maximum positive reinforcement at discontinuous end, so if there is some moment here, so that reinforcement will cater for those small moments. Okay, बात समझ आ रही है? मगर हम इसको बस 0 लेते हैं, क्योंकि अगर आपको याद हो, देखिए ये पैनल अगर फॉर एग्जांपल if it is a one way slab system, if it is a one way slab system, this length is for example 30 feet, sorry 40 feet. Okay, for example मैं कह रहा हूं, and this is 20 feet, so it will become one way panel. इस तरह है कि नहीं?
Yes, sir.
अच्छा, what was the coefficient for this support? Negative moment coefficient याद है आपको? If it is a one way slab system and the exterior support is a beam support, so what was the coefficient, the negative moment coefficient? कुछ याद है आपको?
सर 0 होगा.
No, for beam support it was 1/24, if you remember. याद है?
Yes, sir.
तो अगर ये फॉर एग्जांपल if it is a two way slab system, तो ये मजीद कम हो जाएगा, क्योंकि some of the moment will be also taken by this side, तो ये मजीद कम हो जाएगा. ये तो ऑलरेडी बहुत कम वैल्यू है 1/24, और ये अगर मजीद भी कम हो जाए तो उसको हम इग्नोर कर सकते हैं. तो that is why we are taking 0 moment at discontinuous end. अब समझ में आ गई बात? यानी अगर आप ये नेगेटिव मोमेंट फॉर टू वे स्लैब अगर हो, जिस तरह ये केस है, इसके लिए कैलकुलेट कर तो इट विल बी लेस देन दिस कोएफिशिएंट, फॉर एग्जांपल 1/40 or 1/30. So this coefficient value and the moment coming from this coefficient will be so small. समझ गए? तो उसको हम इग्नोर कर सकते हैं. सही है? क्लियर? हेलो?
जी सर, क्लियर है यहाँ तक.
अच्छा.
Yes, sir.
Now we will calculate the positive moment along the longer direction and the positive moment along the shorter direction. Okay, so we have already these coefficients. Using those coefficients we can calculate CA positive dead load was how much? जल्दी बताए शाबाश.
0.039.
0.039. And CA positive live load was how much?
0.048.
0.048. Now from this we can calculate the positive moment along the shorter direction. It will be equal to CA positive dead load multiplied by ultimate dead load multiplied by LA square or LB square?
LA square.
LA square plus CA positive live load coefficient multiplied by ultimate live load multiplied by LA square. तो जरा इसमें पुट करें. CA positive dead load is 0.039 multiplied by ultimate dead load. How much was the value? याद है?
0.162.
0.162 multiplied by LA square. So how much?
19 square.
19 square plus CA positive live load is 0.048 multiplied by how much was the ultimate live load?
0.064.
0.064 multiplied by LA square, so 19 square. So what will be the value?
3.39.
3.39 foot hit per foot. Okay, so this is the positive moment along the shorter direction. Now positive moment along the longer direction. अब हम कैलकुलेट करते हैं, but qualitatively can you tell me MB positive will be greater than this moment or less than this moment? Moment
Less than. Less than.
less than this moment, because we have already derived that moment transfer along the shorter direction will be more as compared to the load transfer along the longer direction. मगर अब इसको हम कैलकुलेट करते हैं. सही. इस तरह आप नेगेटिव मोमेंट में भी आपने देखा, नेगेटिव मोमेंट में भी the negative moment along the shorter direction you can see 5.8. It is greater than the negative moment along the longer direction. So qualitatively you know these things, but you have to quantifiably calculate these moments for the design. Okay. Clear? यहाँ तक clear है?
Yes, sir.
जी सर. जी सर.
अब इसको जरा कैलकुलेट करते हैं एम बी पॉजिटिव को. तो फर्स्ट ऑफ ऑल सी बी पॉजिटिव डेड लोड कोएफिशिएंट वाज हाउ मच? कोएफिशिएंट की वैल्यू याद है?
0.016, sir.
0.016. And what about the CB positive live load?
0.02.
0.02. ओके. तो इससे अब आप खुद जरा कैलकुलेट करें. शाबाश. कैलकुलेट एम बी पॉजिटिव. हरी अप. How much is the value?
2.23.
So this will be equal to 0.016 multiplied by 0.162 multiplied by 24 square plus 0.02 multiplied by 0.064 multiplied by 24 square. So how much is the value?
2.23.
2.23 foot cube per foot. You can see this value is less than 3.39. Okay, and you have calculated the exact value now using these coefficients. तो इसको भी जरा उस पैनल पर मार्क कर देते हैं. तो ये जरा नोट करें. MA positive is 3.39 and MB positive is 2.23.
सर
जी
सर ये पॉजिटिव मोमेंट में हमने डेड लोड और लाइव लोड दोनों को लिया हुआ था ना, तो ये नेगेटिव में दोनों को नहीं लेते ना?
नहीं, नेगेटिव को में एक को लेंगे, टोटल अल्टीमेट लोड को.
अच्छा सर,
उसके लिए कोएफिशिएंट की वैल्यू भी एक है.
ओके सर.
सही. पॉजिटिव मोमेंट के लिए कोएफिशिएंट की दो वैल्यूज हुए, डेड लोड के लिए सेपरेट है और लाइव लोड के लिए सेपरेट है. सही.
ओके सर.
तो यहाँ पर आ जाए जरा. This line shows, this color shows the positive moment along the shorter direction. And what was the value? 3.39 foot cube. Okay. And again, this line and this color shows the moment along the positive moment along the longer direction. And what was the value? Hello?
2.23.
2.23. So now you have completely analyzed panel 1. In this way you can analyze panel 2, panel 3 and panel 4. Okay, and once you get the value of these moments, you can design the slab in the same way, that is using trial and error. You can calculate the design reinforcement. Okay, यहाँ तक क्लियर है?
जी
Yes,
सर.
sir.
Any question in this?
सर ये जो हम लॉन्गर टू शॉर्टर रेशो लेते हैं वो तो हम इस केस में 24/19 लेंगे, और अगर हमें एम फाइंड करना हो तो वो फिर हम 19/24 लेंगे.
हाँ, ये टेबल में इस तरह है ना. ये जो टेबल है इसमें बेसिकली दिस m is shorter to longer span ratio. Okay.
ओके सर.
यहाँ तक कोई क्वेश्चन है?
No, sir.
No, sir.
अच्छा, अब इसके बाद आप पैनल 2 एनालाइज करेंगे. पैनल 2 में भी you will get negative moment at the supports and positive moment at the mid span. अब आप इसमें देखें ना, जब आप पैनल 2 एनालाइज करते हैं, so there will be a moment value at the same support on this support which is common between the continuous support or the interior support which is common between panel 1 and panel 2. यहाँ पर एक वैल्यू आएगी from the analysis of panel 2. इस तरह है कि नहीं?
यस सर.
फॉर एग्जाम्पल ये ग्रीन लाइन आप देखें ना, दिस इज द नेगेटिव मोमेंट एट द सेम सपोर्ट कमिंग फ्रॉम द एनालिसिस ऑफ पैनल 2। बात समझ में आ गई?
यस सर।
अब आप डिजाइन के लिए कौन सा लेंगे, रेड वन और ग्रीन वन?
सर एवरेज
जी
इनका सब
दोनों
लेंगे
की एवरेज।
जो मैक्सिमम हो सर।
हाँ,
Zero.
maximum of these two will be taken for the design. Okay, which one is greater? Okay, so maximum of these two will be taken for the design finally. बात समझ में आ रही है? इसी तरीके से जो भी कॉमन साइड्स हैं, अगर आप पैनल 3 को एनालाइज करें तो फ्रॉम द एनालिसिस ऑफ पैनल 3 you will get a moment value at this support, and at the same support you will get the moment value from the analysis of panel 2. इसमें भी जो मिक्सिम होगा you will pick that for the design. Okay, similarly अगर आप पैनल 3 को एनालाइज करें तो यहाँ पर जो आपने येलो कलर की जो 3.77 आ रही है, यहाँ पर एक और वैल्यू आएगी फ्रॉम द एनालिसिस ऑफ पैनल 3। बात समझ में आ गई? तो उन दोनों में आप मैक्सिमम लेंगे।
सर और पॉजिटिव मूवमेंट के लिए?
पॉजिटिव मूवमेंट के लिए तो एक वैल्यू है ना, वो तो हर एक पेन की अलग वैल्यूज है ना। देखिए ये आप देखें, दीज आर सेपरेट वैल्यूज फॉर ईच पैनल। मगर नेगेटिव मोमेंट में अगर इफ यू सी दिस सपोर्ट इज कॉमन बिटवीन पैनल 1 एंड पैनल 3, this support is common between panel 1 and panel 2. See, this is common between panel 3 and panel 2, and this support is common between panel 3 and panel 4. बात समझ आ गई कि नहीं?
ओके सर, ओके।
पॉजिटिव मोमेंट के तो अपने सेपरेट वैल्यू होंगे ना, मगर नेगेटिव मोमेंट की जो कॉमन सपोर्ट हो बिटवीन द टू पैनल्स, सो फ्रॉम द एनालिसिस ऑफ द टू पैनल्स यू विल गेट डिफरेंट वैल्यूज। ये पॉइंट क्लियर है?
Excuse me, sir.
जी जी
Sir, if we get the value of m exactly not equal to 0.8%, so what we do? We take as a proposition.
दोबारा जरा पूछे।
सर
If m-
अगर हमारे पास m की वैल्यू एग्जैक्टली हमारे पास टेबल में गिवन है ना?
हाँ, वो तो क्लोजर टू दीज वैल्यूज आप लेंगे। फॉर एग्जांपल आपके पास है 0.72, तो इट इज क्लोजर टू 0.7, तो बस आप 0.7 लेंगे। अगर आपके पास है 0.74, इट इज क्लोजर टू 0.75, तो आप 0.75 लेंगे।
ओके सर, थैंक यू।
बात समझ गए? एनी अदर क्वेश्चन? चले एक 10 मिनट्स का ब्रेक करते हैं और उसके बाद फिर वी विल स्टार्ट द डिजाइन ऑफ ए टिपिकल हाउस। ओके
सर ना मेरा एक क्वेश्चन है
जी।
सर। ये पैनल 1 में जो आपने ये दो मूवमेंट लिए पॉजिटिव, एक शॉर्टर डायरेक्शन के लिए और एक ये लॉन्गर डायरेक्शन के लिए, तो ये मिड पॉइंट पे ऐड नहीं होंगे?
नहीं, लॉन्गर डायरेक्शन की मोमेंट के साथ उसका कोई ताल्लुक नहीं। दिल बी मोमेंट अलोंग द लॉन्गर डायरेक्शन एज वेल एज द मोमेंट अलोंग द शॉर्टर डायरेक्शन। आप लोगों ने पढ़ा है कि मोमेंट ट्रांसफर अलोंग द शॉर्टर डायरेक्शन हमने कैलकुलेट किया था, डिराइव किया था, इट विल बी मोर एज कंपेयर टू द मोमेंट ट्रांसफर अलोंग द लॉन्गर डायरेक्शन। ये तो हमने प्रूव किया था। यहाँ पर आप देखें ना, दोबारा इसको जरा देखें। इफ एल बी बाई एल ए इज 2, तो उसमें उस केस में almost moment transfer along the shorter direction will be 4 times the moment transfer along the longer direction. Okay,
sir.
so there will be different moments. If it is a perfect square panel, if both sides are same, for example, so then moment transfer along both direction will be same, because यहाँ पर आप 1 put करें ना, L by LA is equal to 1, so MA will be equal to MB. ये कॉमन सेंस से भी आपको पता है कि मोमेंट
यस
कौन सा
सर,
है, लैंग्वेज डायरेक्शन भी सेम, सही।
सही है। तो फिर हम इसके लिए अगर MA के लिए हम डिजाइन कर ले तो वो फिर MB के लिए भी काफी होगा दोनों साइड में।
हाँ बिल्कुल, मगर आपने कुछ इकोनोमाइज तो इसको करना है ना। तो अगर आप दो स्पेसिंग कर सकते हैं कि MA के लिए आप डिफरेंट स्पेसिंग प्रोवाइड करें और लॉन्गर डायरेक्शन के लिए आप डिफरेंट स्पेसिंग प्रोवाइड कर सकते हैं टू इकोनोमाइज।
ओके सर।
इट विल बी सेफ, इट विल बी कंजर्वेटिव। अगर आप MA के लिए करें एंड इफ यू प्रोवाइड दैट स्पेसिंग इन बोथ डायरेक्शन, दैट विल बी कंजर्वेटिव, but to economize the project you can also provide different spacing along both direction. Okay,
ओके सर।
so we will take a break of uh, 10 minutes and then we will start the lecture again from this. अगर ये clear हो तो बस बाकी design में the same procedure, trial and error. You can calculate the design reinforcement from trial and error once you get the values of moment. Okay.
Can we leave the class?
Okay, I think so. We should start the lecture now. These are the steps for moment coefficient method of two-way slab system. So now you can very easily calculate pick the moment coefficients as well as calculate the moment values for two-way slab system. These steps are very simple. First of all, you will calculate the thickness of slab. So in case of two-way slab system, the total perimeter of the slab panel. आवाज आ रही है?
ये सर आ रही है
Okay. So total perimeter divided by 180. This will give you the thickness of slab. So in our case, the panel was 20 by 25. 20 by 25. So the total perimeter will be equal to 2 multiplied by 20 plus 25 divided by 180. So this is equal to 90 divided by 180. 0.5 feet or 0.5 multiplied by 12. So h is equal to 6 inch is required for our case, which we have analyzed. And you already selected h is equal to 6 inch. Okay? Clear? Hello?
Yes, sir, clear.
So first of all, you will calculate the minimum thickness. Calculate load on slab in the same way. Calculate M, which is LA divided by LB. Shorter side divided by longer side. Decide about the case of slab. अब आप लोग जानते हैं कि किस तरह करना है. Use tables to pick moment coefficients. So for 6 different coefficients, you will pick the values from 6 different tables. Calculate moments, ये भी आप कर सकते हैं. Apply reinforcement requirement. So for two-way slab system, the maximum spacing requirement is 2h. Okay. In case of one-way slab system, if you remember, for main reinforcement 3h or 18 inch. That was the maximum spacing allowed. But in case of the two-way slab system, now the maximum spacing requirement is 2h. Okay. So maximum spacing shall not be greater than 2h. Clear? Is it clear to all of you?
Yes, sir,
Yes,
clear.
sir.
Now we will come to the design of a typical house with 2 rooms and a veranda. So if you see the floor plan of this house, so it consists of 3 panels: panel 1, panel 2 and panel 3. What about panel 1 and panel 2? Is this a one-way slab system or two-way slab system?
Two-way slab system is, sir.
It is a two-way slab system because 16 divided by 12 is equal to how much?
1.33.
1.33, which is distant 2. And what about panel 3? It is a one-way slab system or two-way slab system? Panel 3.
Sir,
ये
one
one
way.
way. One way.
It is a one-way slab system because the total length of the veranda, it is almost 33 feet or 32 feet, and the width of veranda is 9 feet. So 32 divided by 9, it is greater than 2. So that is why it is a one-way slab system. And the boundary condition of panel 1 and panel 2 is same. So you can treat it as the same, क्योंकि आप देखें two ends are discontinuous and two ends are continuous. Similarly for panel 2, two ends are discontinuous and two ends are continuous. So it means that if you analyze panel 1 and panel 3, so you analyze the complete floor system, because panel 1 and panel 2 is same. Clear? यहाँ तक क्लियर है?
Yes, sir.
अच्छा, अब इसमें एक पॉइंट है कि this is not a two-way slab system strictly, nor it is a one-way slab system. It is kind of a mixed system, which is combination of two-way slab system and one-way slab system. अब इसमें मसला क्या है? The problem is, जो हमने one-way slab system के लिए कोएफिशिएंट्स पढ़े थे, that is applicable to a one-way slab system which is continues with another one-way slab system. अगर आपको याद हो हाल जो हमने पढ़ा था, तो उसमें there were beams along the shorter direction. This was a one-way slab panel. It is continues with another one-way slab panel, continues with another one-way slab panel. So those slab coefficients were applicable to only one-way slab system. Okay, and the coefficients which we are studying in this lecture, which we calculate from those tables, it is also applicable to the two-way slab panel, which is continues with another two-way slab panel. बात समझ में आ रही है?
Yes, sir.
मगर इस केस में आप देखें, two-way slab is continues with one-way slab system and one-way slab is continues with two-way slab system. So for this case, those coefficients will not be applicable. और उसकी रीजन क्या है? रीजन ये है कि एक तो डिराइव्ड हुए हैं वन वे स्लैब सिस्टम के लिए कोएफिशिएंट्स, टू वे स्लैब कोएफिशिएंट्स टू वे स्लैब सिस्टम के लिए डिराइव हुए, मगर यहाँ पर जो मेन प्रॉब्लम है वो कहाँ पर आएगा? द कॉमन सपोर्ट बिटवीन वन वे स्लैब सिस्टम एंड टू वे स्लैब सिस्टम. ये जो वॉल है, this long wall which is common between the two-way slab system and the one-way slab system. Okay, क्योंकि if you analyze this panel 1 or panel 2, you will get a moment value here. Okay, and if you analyze a one-way slab system veranda, again you will have another coefficient which will be corresponding to one-way slab coefficient. Okay, तो हम क्या करेंगे to resolve this issue? बस उसी तरीके से हम करेंगे, maximum of these two will be taken for the design. बात समझ में आ रही है? अगर वन वे स्लैब, अगर आपको याद हो इस डायरेक्शन में अगर आप देखें, so there are two spans. तो two spans के लिए, do you remember what is the negative moment coefficient for the interior support?
1/9.
1/9. तो आप लोगों को एडवांस में पता है कि 1/9 into WU ln square ln of this veranda will be taken. This will come from the one-way slab, and for the two-way slab you will pick this moment from the table. Okay, तो एक 1/9 से आएगा, 1/9 WU ln square, where ln is the clear length of the veranda. और एक मोमेंट आएगा फ्रॉम द एनालिसिस ऑफ टू वे स्लैब पैनल, दैट इज द एनालिसिस ऑफ दीज रूल्स। ओके, क्लियर? इनमें से जो मिक्सिम है दैट विल बी यूज फॉर द डिजाइन। क्लियर? अच्छा, गिवन डेटा service dead load consists of 4-inch thick mud layer and 2-inch thick brick tile. Again, it is very simple. You will calculate the loads from this thickness of the mud multiplied by its unit weight, thickness of tile multiplied by its unit weight. Live load is given by, it is given, can be picked from a C table. It is 40 pieces for residential building. If C prime 3 KSI and FY 40 KSI. ओके, अच्छा, अब स्लेब थिकनेस भी आप दो तरीकों से कैलकुलेट करेंगे, एक वन वे स्लेब के लिए और एक टू वे स्लेब के लिए। इस तरह है ना, टू वे स्लेब के लिए आपको पता है दैट H विल बी इक्वल टू पेरीमीटर 2 मल्टीप्लाइड बाई 12 प्लस 16 डिवाइड बाई 180। इससे आप कैलकुलेट कर सकते हैं, ये जरा कैलकुलेट करें, शाबाश। हरी अप।
सर ये 3.7 इंच आ रहा है।
3.7 इंच। ओके, एंड फॉर वन वे स्लेब सिस्टम विद वन एंड कंटिन्यूस, याद है आपको इक्वेशन, H was equal to L divided by 24, I think, one in continuous by 24 है, and multiplied by, since it is grade 40, so multiplied by 0.8. okay, so L in this case you can calculate by ln plus H and L center to center, whichever is the मिनिमम। ओके, तो इनसे आप कैलकुलेट कर सकते हैं। फॉर एग्जांपल हम टोटल ये 9 फीट लेते हैं, ठीक है, तो 9 डिवाइड बाई 24 मल्टीप्लाइड बाई 0.8 मल्टीप्लाइड बाई 12, ये जरा करें।
इंच
3.6 इंच। तो आप, हम एज्यूम करेंगे H is equal to 5 inch, which is greater than both of these two values. Okay, so H is equal to 5 inch will be sufficient for the given house floor system. Okay,
सर ये टू वे स्लेब वाले सर रिवाइज कर दें प्लीज।
टू वे सिस्टम तो बिल्कुल सिंपल है, पैरामीटर आप कैलकुलेट करेंगे। पैरामीटर आप लोगों को पता है, शॉर्टर साइड प्लस लॉन्गर साइड मल्टीप्लाइड बाई 2 डिवाइड बाई 180, और इसको 12 में मल्टीप्लाई करें टू कन्वर्ट इट इनटू इंचेस।
ओके ओके, शुक्रिया सर।
सही, तो आगे आप देखें जरा, इन्होंने यहाँ पर इस तरह किया है कि H मिनिमम फॉर टू वे स्लेब इज कैलकुलेटेड विच इज कमिंग 3.73। अभी हमने भी कैलकुलेट किया, तो हमने यहाँ पर एज्यूम किया है 5 इंच, बिकॉज 5 इंच इज ग्रेटर देन 3.73 इंच। अब फॉर 5 इंच आप वन वे स्लेब के लिए भी आप कर सकते हैं, बिकॉज ln प्लस H एंड L सन टू सेंटर मिनिमम ऑफ दिस टू इज 8.42। आप 8.42 करें यहाँ पर, सिंस इट इज वन एंड कंटिन्यूस। ओके, तो इट इज L by 24 multiplied by 0.8, it is coming 3.367 inch. It means that 5 inch slab will be sufficient for both one way and two way slab. Okay, यहाँ तक क्लियर है?
जी सर।
अच्छा, अब आप देखें टोटल जो वेरांडा width of the veranda, it is 9 feet. Okay, but we have provided a 12-inch beam here at the exterior side. ये आप B1 नजर आ रही है, this beam is having 12-inch width. Okay, तो उससे अगर आप ये माइनस करें So the clear length of veranda is 8 feet. Clear?
Yes, sir. Clear.
अच्छा, आप स्टेप बाय स्टेप आ जाए. लोड. So first of all, self weight, thickness of slab multiplied by unit weight, it is coming 0.0625. 4-inch mud layer, thickness multiplied by unit weight, it is 0.04 kSif. 2-inch tile, thickness multiplied by unit weight, 0.02. So total dead load will be the sum of these three. It is coming 0.1225. From this you can calculate the ultimate dead load. So 1.2 multiplied by 0.1225, it is coming 0.147 kSif. Okay. Similarly, ultimate live load is equal to 1.6 multiplied by 40 psif or 0.04 kSif. It is coming 0.064 kSif. And the total factor load will be equal to 0.147 plus 0.064. It is coming 0.211 kSif. Why we calculated these separately? Because now you know that for positive moment calculation, we need ultimate dead load and ultimate live load separately. अब तो आपको पता है ना?
जी सर.
अच्छा. Now coming, again this is the same discussion जिस तरह मैंने आपको बताया कि coefficient method जो है, it is, this system consists of both one-way and two-way slabs. Rooms two-way slab are continuous with veranda one-way slab. A system where a two-way slab is continuous with one-way slab or vice versa can be called as mixed slab system. यहाँ पर आप देखें वही बात है, ACI approximate method of analysis are not applicable to such system because in case of two-way slabs the moment coefficient tables are applicable to two-way slab system where a two-way slab is continuous with a two-way slab system. ये already हम discuss कर चुके हैं. See, similarly जो ACI coefficient for one-way slab है, it is applicable to one-way slab where a one-way slab is continuous with another one-way slab. बात समझ में आ गई? तो इस इशू को हम रिजॉल्व किस तरह करेंगे, मैंने आपको बताया कि द मोमेंट कमिंग फ्रॉम वन वे स्लैब एनालिसिस, द नेगेटिव मोमेंट at the common support between one-way and two-way slab system will be calculated from two-way slab system analysis and one-way slab analysis, and maximum of the two will be picked for the design. बात समझ आ गई? यहाँ पर आप one moment value will come from the one-way slab analysis and another moment value will come from the two-way slab analysis. Maximum of these two will be picked for the design. The best approach, अच्छा आप जरा देखें यहाँ पर, the best approach to analyze a mixed system is to use finite element software. तो असल तरीका तो ये कि आप इसको finite element software में analyze करें. Using finite element analysis आप इसको analyze कर सकते हैं. However, such a system can also be analyzed manually by making certain approximations. In the next slide, we will analyze this system using both of above methods. अब देखें, first of all, this is the analysis of the system, the whole floor, using finite element software. इसको फिर हम कंपेयर करेंगे ऐसे कोएफिशिएंट मेथड की मोमेंट वैल्यू से. सही, इसको आप जरा देखें ना. दिस शोज डायग्राम शोज द मोमेंट डायग्राम along the longer direction. करेक्ट? तो आप देख सकते हैं एम बी पॉजिटिव. अब तो आप ये कोएफिशिएंट पता है ना, along the longer direction we denoted by MB, and this is MB negative. So MB positive is this one, it is 1.17 foot kip per foot, and MB negative is this one, which is 1.67 foot kip per foot. These are the analysis results coming from the software. Okay, we have modeled the same slab in the finite element analysis software safe, and these are the results. Okay, आगे फिर उसको हम एशियाई कोएफिशिएंट मेथड से भी सॉल्व करेंगे. सही, यहाँ तक क्लियर है?
जी सर.
What about the moment along longer direction in veranda? Moment along the longer direction in veranda. It will be 0. इस तरह है कि नहीं?
Yes, sir.
Why? Because
Shorter direction में जाएगा.
because there will be no load transfer along the longer direction, so it will be almost equal to 0. Now, if we analyze the same along the shorter direction, तो वहां पर आप देखिए अब जरा. This is MA positive, okay. This is MA negative at the common support between two-way and one-way slab system, and this is the positive moment in veranda. अब आप देख सकते हैं moment को, ये moment आप देख सकते हैं. Along the shorter direction there will be positive moment, but along the longer direction there is no moment, okay. So MA positive is 1.58 from the software. MA negative, it is the true value, it is 2.10, and M veranda, positive moment in the veranda, it is 1.10. These are the finite element analysis results, okay. यहाँ तक clear है?
Yes, sir.
Yes, sir.
अब ये आप देखिए, this is one value and this is the true value of negative moment at the support, क्योंकि finite element analysis है ना, ये तो approximate analysis है नहीं. अब इसको moment को हमने compare करना है the negative moment value coming from the ACI coefficient method. तो उसमें मैंने आपको बताया था that one value will come from the two-way slab analysis, another value will come from the one-way slab analysis, and maximum of these two will be picked for the design, okay. और उसको हम फिर कंपेयर करेंगे इस MA नेगेटिव से which is coming from the finite element analysis results, okay. Clear? Hello?
Yes, sir. Clear है.
अच्छा, now moment coefficient method for analysis. यहाँ पर आप जरा आए. First of all, we will analyze the two-way slab system. So since both are same, so if we analyze one of these panel, so both will be analyzed basically, okay. तो ये केस तो आपको याद है, two ends are continuous and two ends are discontinuous. ये कौन सा केस है? Previously हम
Yes, 4.
fourth केस है बिल्कुल. तो फर्स्ट ऑफ ऑल आप m कैलकुलेट करेंगे, because for table you need m. M is equal to 12 by 16, it is 0.75, it is 0.75, and case is case 4. तो CA नेगेटिव आप देख सकते हैं, it is 0.076. क्लियर? अब मैं क्विकली जाता हूं क्योंकि आप लोगों को पता है कि हाउ टू पिक दीज कोएफिशिएंट वैल्यूज, ओके. CB नेगेटिव, it is 0.024. CA positive dead dot 0.043, CB positive dead dot 0.013, CA positive live load 0.052, and CB positive live load is 0.016. Clear?
जी सर.
Now from these you can calculate the moments. Okay. So the moments finally, अब आप मोमेंट तो कैलकुलेट कर सकते हैं ना?
Yes, sir.
अच्छा, तो फाइनली इसकी वैल्यू जरा देखें. MA नेगेटिव is 2.31 foot cube, and what is MA negative? MA negative is this one. MB negative is 1.29, so this is 1.29. Okay. MA positive is 1.39, this is 1.39, and MB positive is 0.75, दिस वन इज 0.75. ओके, ये वैल्यू जरा नोट करें ताकि हम उस पैनल पर इसको मार्क कर सके. वैल्यू नोट करें, शाबाश. MA negative 2.31, MB negative 1.29, MA positive 1.39 and MB positive 0.75. नोट किया?
जी सर.
अच्छा, अब इसको जरा यहां पर मार्क कर देते हैं. सही. So what was the value of MA negative?
2.31.
This is basically MA negative, and the value of this was 2.31. Okay. What about the MB negative?
1.29.
So MB negative is equal to 1.29 foot. What about the MB positive?
0.75.
And what about the
MA positive
MA
1.39.
positive? How much?
1.39.
1.39. Now if you see this one, MA negative, so this support is common between one-way and two-way slab system. So this value, we will also calculate this value from one-way slab analysis to check which one of the value of these value is maximum. Okay, तो अगर हम इस वेरांडा को एनालाइज करें तो आप लोगों को ऑलरेडी पता है कि there is a beam at the exterior side. Okay, so what will be the negative moment value at the beam coefficient? बताइए जरा, शाबाश. कितना आएगा यार?
1/20.
1/24. And positive moment coefficient, यार इसको अगर आप सेक्शन इसकी अगर आप ड्रा करें ना, section AA for example, so it will look like this. इस तरह है ना, ये 1/24 है और पॉजिटिव मोमेंट कोएफिशिएंट कितना होगा? It will be 1/14. And what about these coefficients? Hello? टू स्पेस के लिए यार इंटीरियर नेगेटिव मोमेंट कोएफिशिएंट कितनी थी?
1/9.
1/9. आप क्यों यार रिस्पॉन्ड नहीं कर रहे? इट इज 1/9. ओके, तो 1/24. यहाँ पर हमारे पास
1.9 सर.
1/14 और यहाँ पर है 1/9. इस तरह है ना. तो इससे भी आप नेगेटिव मोमेंट कैलकुलेट करें. दैट इज वेरी सिंपल. ओके, M negative from this is equal to 1/9 into WU into ln square. So 1/9 WU टोटल अल्टीमेट लोड कितना था? What was the value of total ultimate load यार? 0.211. Clear? Hello?
Yes, sir.
Yes. It is 0.211. And what is the clear length of veranda?
8.
8
8 square. तो ये जरा कैलकुलेट करें शाबाश. M negative coming from the one way slab analysis.
1.5 12 से मल्टीप्लाई कर दूं?
नहीं फुट किट में
सही है 1.5.
1.5
1.5. तो 1.5 foot kip is coming at the same support from one way slab. तो इसको मैं एक डिफरेंट कलर से शो कर देता हूँ. ओके this color is showing the moment coming at the same support from one way slab analysis. And what was the value? Sorry, ये कलर
1.5.
ये कलर मैं चेंज कर देता हूँ. Yeah, this will be not visible on the slide. Okay, this color is showing the moment, negative moment coming from one way slab analysis. Okay, at the same support. How much was that? 1.5 foot kip. Clear?
Yes, sir.
Now, which one of these two will be picked for the design? ये हम pick करेंगे या ये?
2.31.
2.31 मैक्सिमम लेंगे.
Yes. So you will pick 2.31 for the design. और वेरांडा की डिजाइन के लिए आप ये भी कैलकुलेट कर सकते हैं. 114. ये जरा कैलकुलेट करें शाबाश. M positive for veranda. It is equal to 1/14 WU, which is 0.211 into ln square, which is 8 square. These are calculated करें शाबाश.
.96.
0.96 फुट के. ओके, अब इसको जरा कंपेयर कर देते हैं फाइनाइट एलिमेंट एनालिसिस रिजल्ट्स के साथ. ओके, तो ये वैल्यू जरा नोट करें शाबाश. एम ए पॉजिटिव 1.39, एम ए नेगेटिव 2.31, एम बी नेगेटिव 1.29, एम बी पॉजिटिव 0.75, एम नेगेटिव कमिंग फ्रॉम दी. सो वी विल टेक this one out of these two. उसमें बस आप सिर्फ इसको नोट करें. एंड m पॉजिटिव फॉर वेरांडा इज 0.96. ये 5 वैल्यू जरा नोट करें. नोट किया?
जी सर.
आप इसके साथ कंपेयर करें. मुझे एक एक वैल्यू बताए शाबाश. व्हाट वाज द वैल्यू ऑफ ma पॉजिटिव?
1.39.
1.39. mb पॉजिटिव
0.75.
0.75. ma नेगेटिव
2.31.
31. mb नेगेटिव
1.29 लेंगे सर.
1.29. and m positive for veranda
0.96.
0.96. अब आप इसको जरा कंपेयर करें फाइनाइट एलिमेंट एनालिसिस रिजल्ट्स के साथ. So all these values are closer to each other. There will be some difference, of course, because it is the slab coefficient method is a approximate method, but the values are closer to each other. Okay, but if you take 1.5, that is moment coming at this support from the one-way slab analysis, it is not closer to this value, so it means that maximum of these two will be picked for the design. Okay, clear?
जी सर.
इसमें कोई क्वेश्चन है? एनी क्वेश्चन? तो आगे आप जरा देखें. You can see for veranda it is 1.5 foot kip, 124 for exterior, 114 for interior, and this is one-to-one comparison. ये आगे हमने अभी किया. Analysis results from safe and from manual. Analysis results from both approaches are almost similar. Hence, the intelligent use of manual analysis yields fairly reasonable results in most cases. Okay. Now, design is very simple. Again, the same way. First of all, you will calculate the minimum reinforcement, and you will calculate the capacity corresponding to minimum reinforcement. If that capacity is greater than all those demand moment values, so you will use the minimum reinforcement. If some of the moments are greater than the capacity, then you will calculate the design reinforcement for those moments values. Okay. So A is minimum is 0.0018 BH, as I told you that now in ACI 318-19, minimum reinforcement for slab is 0.0018 BH for any grade of steel. Okay, it is coming 0.11 square. If we are using number 3 bar, so spacing for this reinforcement, it is 0.11 divided by 0.11 multiplied by 12, so 12 inch spacing is coming for number 3 bar. But you know that for two-way slab system, there is a requirement that maximum spacing shall not be greater than 2 inch. अभी पिछले slide पर हमने पढ़ा सही. So the maximum spacing coming from this is 10 inch. Okay, so it means that 10 inch spacing is governing. Clear है कि नहीं?
जी सर.
So what you will do, since 10 inch spacing is governing, so you will calculate minimum reinforcement based on this spacing. So that is very simple. AS minimum is equal to 0.11, which is bar area, divided by spacing, which is 10. तो बार तो आप वही नंबर 3 यूज कर रहे हैं ना, मगर स्पेसिंग आप 10 इंच यूज करेंगे, तो उससे आप reinforcement कैलकुलेट कर सकते हैं and multiply it by 12. So 0.132 inch square is basically the minimum reinforcement. Clear?
ओके सर.
Yes, sir.
अच्छा, अब एस मिनिमम कंप्रेशन ब्लॉक डेप्थ करस्पॉन्डिंग टू एस मिनिमम आप कैलकुलेट कर सकते हैं 0.132 multiplied by fy divided by 0.85 c prime b, so it is coming 0.17. आप इस इक्वेशन में आप पुट करें, so you will get the capacity corresponding to minimum reinforcement corresponding to number 3 at 10 inch spacing. इसका क्या मतलब है? If you are providing number 3 at 10 inch spacing, okay, it will give you this much capacity, 18.6 inch kip. बात समझ में आ रही है? अब यहां पर आप जरा देखें, यहां पर जो हमने मार्क किए हैं ये वैल्यूज आप जरा देखें, इसको आप फिर में मल्टीप्लाई करें टू कन्वर्ट इट इनटू इंच किप. शाबाश, 1/1 1.39 मल्टीप्लाई बाय 12 करें, कितना आ रहा है मोमेंट?
सर 16.68.
16.68. 2.31 multiplied by 12,
27.72.
27.7. 1.29 multiplied by 12,
15.48.
15.5. And 0.75 multiplied by 12,
9.
9 inch cube.
जी सर 9.
And 0.96 multiplied by 12.
11.52.
11.52. तो अगर आप देखें, the capacity is greater than all these demand moment values. This one, this one, this one, except MA negative, which is at this support. बात समझ में आ रही है?
Yes, sir.
The capacity corresponding to number 3 at 10 inch spacing, it is greater than all the demand moment values except the negative moment at the support which is common between two-way slab and one-way slab system. तो आप क्या करेंगे? It means that you can provide the number 3 at 10 inch spacing everywhere except the top reinforcement at this support. उसके लिए आप ट्रायल एंड एरर से स्पेसिंग कैलकुलेट करेंगे. बात समझ में आ रही है? तो 27.7 के लिए आप स्पेसिंग कैलकुलेट करेंगे. If you calculate spacing from trial and error, so 6 inch spacing will be sufficient. Number 3 at 6 inch spacing will come from the trial and error. Okay. तो इसका मतलब ये फाइनली कि यहाँ पर आप नंबर 3 at 6 inch spacing प्रोवाइड करेंगे and everywhere else आप प्रोवाइड करेंगे नंबर 3 at 10 inch. क्लियर?
Yes, sir.
तो
Okay,
अगर मैं
sir.
यहाँ पर अगर मैं ये करूं ड्राफ्टिंग इन दी प्लेन, तो for example the bottom reinforcement is represented by M1, bottom reinforcement represented by M1. Okay, top reinforcement is represented by, at this support it is represented by MT1, and at this support it is represented by, for example, MT2. Okay, so M1 will be how much? M1 is equal to number 3 at 10 inch. Okay, MT1 is how much? Quickly, again number 3 at 10 inch. And what about MT2? How much spacing is required? Number 3 at 6 inch center. And all at all discontinuous ends, जो discontinuous ends है, इस पर आप प्रोवाइड कर सकते हैं in the top. In the top you will provide इसको अगर हम रिप्रेजेंट करें with MT3, तो MT3 will be equal to number 3 at 18 inch spacing. वैसे तो आप ज़्यादा स्पेसिंग भी दे सकते हैं because number 3 at 10 inch is positive reinforcement and you can provide 1/3 of the positive reinforcement at discontinuous end. तो ये कितने स्पेसिंग आप दे सकते हैं? Number 3 at 30 inch. इस तरह है ना? But
जी सर
however
बिल्कुल.
you will not provide spacing greater than 18 inch. तो ये आपके पास है number 3 at 18 inch center. Okay. So this is how you will draft the. इसके फिर आप सेक्शन बी काटेंगे. फाइनली आप इसको देख सकते हैं यहाँ पर. यहाँ पर आप देखिए जरा. This is the table which is showing reinforcement detailing of the slab, and these are the sections. Section AA is given on this, and section BB is given on along this side. Okay, along the shorter side. You will provide the main spacing closer to the bottom face along the shorter direction. ये तो आप लोगों को पता है, तो आप देख सकते हैं सेक्शन बी भी, the room and this is the veranda, all are number 3 at 10 inch. The supporting bars and a discontinuous end, the bars are at number 3 at 10 inch. This is at 6 inch center to center, and these have been curtailed at 8 by 3. Okay. Any question?
नो सर। सर
तो
काफी है, आज के लिए नमाज पढ़ लेते हैं सर,
हाँ बिल्कुल,
नमाज टाइम
तो
जा रहा
बाकी इसमें आप the next step will be to transfer the load of half veranda to this beam, and for that load you will design the beam, and then from the beam the load will come to this column and you will design the given column for the given loading. ये आसान है, आप लोग खुद भी इसको देख सकते हैं, नेक्स्ट लेक्चर में हम ये कवर भी करेंगे। सही, अगर
है।
आप
सर
इसको
इसमें फुटिंग तो नहीं है ना?
नहीं, फुटिंग भी आप करें ना, खुद करें, खैर प्रैक्टिस हो
जी सर।
जाएगी। सही,
ओके सर।
now if you have any question you can ask the question, otherwise I think this is sufficient for today's class.
जी सर, नमाज भी नहीं पढ़ी और खाना भी नहीं खाया।
अच्छा, सही। And now you can leave the class, okay?